Next question, show that b is equal to e raised to minus x sine 2y is not harmonic. v is equal to e raised to minus x sine 2y. vx equal to differentiating with respect to x e power minus x into minus. Okay, e raised to minus x derivative e power minus x into minus 1 sine 2y. vy means e power minus x is constant with respect to y cos 2y into 2. So you get 2 cos 2y. Now vxx derivative of e power minus x once again e power minus x into minus 1 minus into minus plus. So e power minus x sine 2y. vyy means once again with respect to y. vy with respect to y cos 2y derivative minus sine 2y. So we get minus sine 2y into 2. So already you have a 2 here, so you get 4. Now uxx plus vxx plus vyy. You see vxx plus vyy. If you add these two, this is not equal to 0. Okay, we get minus 3 e power minus x sine 2y, that is not equal to 0. Therefore function is not harmonic. Harmonic means you should get this value 0, right? vxx plus vyy should be equal to 0. They are not equal to 0, therefore not harmonic. So we will continue with the next problem. We'll go. Here is a university question. Verify u is equal to x square minus y is harmonic in the whole plane and complex plane, and find a harmonic conjugate function v of u. So now given u is equal to x square minus y, let us differentiate with respect to x and y. ux is 2x, other term 0. uxx means differentiated once again, you get 2. uy means derivative with respect to y, x square becomes 0, this is 2y. So minus 2y minus 1, minus 2y minus 1. Then uyy means differentiate uy once again, so you get minus 2. Here remaining term 0, you get minus 2. Now uxx plus uyy is equal to 2 minus 2, that is 0. So since it is 0, we say given function is harmonic, that is u is harmonic function. Okay, u is a harmonic function. Now using Cauchy-Riemann equation, let us write the Cauchy-Riemann equation. Now consider this here. Okay, ux vy, uy is equal to minus vx. Now vy is equal to ux, uy we are considering vy and vx. Why do we consider vy and vx? Because we have to find v, right? Our question is u is given, we have to find the harmonic conjugate, that is v we have to find. So I have taken vy and vx. vy is okay. After taking the CR equation, I have taken vy. Okay, vy and what is that? vy and vx. Okay, vy and this is vx. vy and vx. What is vy? vy is ux. ux is 2x. Just now we have the values here. ux is, let me take that. ux is 2x and vx is 2y plus 1. So we take vy ux, that is 2x, and vx is minus uy. So you can consider like this. We are taking vy and vx. vy and vx. We know vy is ux and vx is minus uy. Minus uy. Now vx and uy already we have. ux is, you see, what is ux? ux is 2x and uy is minus 2y minus 1. So 2x minus 2y minus 1. You have a negative sign, you have a minus here. So now this is equation 1 and you can multiply this inside. So you get 2y plus 1. Okay, clear? So here students, all that you have to do is, first we have proved harmonic, and then using Cauchy-Riemann equation we are going to continue with the proof. CR equation is given here. Okay, we have taken the CR equation, and since u is given in the question, given u in the question, we have to find the harmonic conjugate. U is given, we have to find v. So what we are doing is, since we have to find v, we take vy and vx. So we have vy and vx using this ux minus uy, which we have already derived. Ux is there, uy is there, substitute it. Now we get this. Now what we are going to do, consider the first equation vy and integrate vy to find v. Integral of vy is integral of 2x dy with respect to y. Since this is vy, we integrate with respect to y. Okay, vy, so we integrate with respect to y. Important question, carefully you have to do. So when you integrate with respect to y, vy will become v, 2x dy will become 2xy plus 2xy plus h of x. Since this is constant, with respect to y, we take 2x into y. Okay, integration with respect to y. Then with respect to y, constant integrating constant is h of x. It is a function in x. So when you integrate with respect to y, take the constant as a function in x, that is h of x. Now we have v here. So actually what we have to do, we have to find v. U is given in the question and find a harmonic conjugate, that is conjugate function v of u. Harmonic conjugate of u is v. So now we have v here. We have v, but one more thing, you have to find this h of x. Okay. To find h of x, let us take vx now, because vx we have taken here. Okay. Vy we have taken. Vy already taken. So let us take this vx. So now let us differentiate v with respect to x. And we get a equation here. From 3 we can find by differentiating with respect to x. Already we have a vx here, that is equation number 2. Okay. So we will continue with that. V is 2xy plus h of x. Okay. This value 2xy plus h of x. Now differentiate with respect to x, we get vx equal to, differentiation of v is vx. Here x will become 1. So 2y plus h dash of x. 2y plus derivative of hx is h dash of x. Now this is equation number 4. So now this vx is from this v. Okay, this vx is from this v. So already we have a vx here. Already we have a vx, that is equation number 2. So let us take that. The previous equation vx is 2y plus 1. Now comparing 2 and 4. From 2 and 4, this is previous equation. This is what we have derived. LHS is equal, so RHS should be equal. So 2y plus 1 is equal to 2y plus h dash of x. Okay. 2y plus h dash of x is equal to 2y plus 1. So eliminate 2y, we get h dash of x is equal to 1. So now we have h dash of x here. So now what will be h of x? This implies integral of h dash of x is equal to integral 1 dx. Why we are integrating? H dash is here, but we want h of x. So to find h of x, you integrate it. So integral and differential together, we get the function h of x is, integral of constant is c. 1 dx is 1x, right? X plus c. Integral of 1 dx. Integral of dx is x plus integrating constant c. Now we will substitute this h of x in equation number 3. That is, what is equation number 3? 2xy plus h of x. 2xy, v is equal to 2xy plus h of x. v is equal to 2xy plus, what is h of x? h of x is x plus c. So I write x plus c. So this is our v value. So also we can find, this is our conjugate harmonic. Okay, this is conjugate harmonic of u. Also we can find f of z. We know f of z is, it is not asked in the question. If it is asked to find the analytic function f of z, then you can write like this. U is given in the question. What is u value? U value is x square minus y square minus y. X square minus y square minus y plus I into, what is v value? 2xy plus x plus c. So this is our f of z. Okay. So next question you can try on your own. Okay. Just I will give.